Here we're looking at solving 1/3 x squared minus 1/3 x equals negative 50 over 6. So first thing that's jumping out to me is the fact that I have these fractions. Like I don't want to deal with this. I see the x squared and the x, and I see something on the other side, but I want to get rid of these fractions. So what I want to do is multiply by the LCD of 6. I'm going to just clear out these fractions, and then we can rethink about this and reset. So I'm going to multiply everything by 6. And the reason I'm picking 6 is because I have a 3 and a 3 and a 6. So 6 divided by 3 would clear that out, and then 6 over 6 would clear that out. So I'm going to go ahead and distribute. 6 over 3 is 2, and then 2 times 1. So I'm doing 6 times a third. 6 times a third is 6 over 3. 6 over 3 is 2. So that becomes 2x squared. And then I have, again, 6 times a third, which is going to be minus 2x equals, and then the 6's cancel over here, leaving me with negative 50. If I didn't understand that concept of why I picked 6, if I tried 3, it wouldn't work, because if I multiply by 3 over here, this would be 2 on the bottom. And then that wouldn't really help us out too much in this case. Oh, actually it would. You know, it's a weird scenario there, where if we multiply by 3, it could actually help us out, because now that I'm seeing this, sorry, my voice. Now that I'm seeing this, I could actually divide everything by 2. I didn't even notice that when I first did it, because what I'm seeing is, let me just show you this again. If I multiply this by 3, look what happens. 3 is 1, and this becomes 2. Luckily, this is negative 50. 50 is divisible by 2, so that's why it works out. If this wasn't 50, if this was like 49 or 51, it wouldn't work. We'd have to multiply by the 6. But that was actually a lucky accident, because now I see 2 and 2 and 50, so I could actually divide everything by 2. So I'm going to do that, divide by 2. That was not intentional. I did not catch that when I was first going through this problem. Just now. I just thought, wipe out that fraction, so you multiply by the LCD. But you could actually do 3. Wow. So 2's. So 2's cancel there. So x squared minus x equals negative 50 divided by 2 is negative 25. Now I'm in this like weird position where, like, okay, that doesn't really, like, this isn't looking very promising in terms of like actually factoring. So I want to get this over here. I want to set this equal to 0 because I'm forming a trinomial here. So x squared minus x plus 25 equal to 0. What we'd want to have happen from here is we'd want to factor the trinomial. Like, we'd want something to multiply here, so this would be x and x, and then we'd want 2 terms here that would multiply to 25 while also adding up to negative 1. Not going to work, because 25 is 5 times 5. That's not going to help us out. So in this case, we can either complete the square or use quadratic formula. I'm just going to use quadratic formula. So quadratic formula is negative b plus and minus the square root of b squared minus 4ac all over 2a. So we're going to take that information, we're going to plug it in. My a value is 1, my b value is negative 1, and my c value is 25. And I want to go back to this line real fast where I had this. If I didn't catch that divisible by 2, I'd have to add over the 50, and then my a term would be 2, my b term would be negative 2, my c term would be positive 50, because I'd have to add over the 50. So it's not like we'd have a completely different answer. We'd just be dealing a little bit bigger numbers, and that's okay. So negative b plus and minus square root of b squared minus 4ac all over 2a. So we're going to have negative b. b is negative 1, so I'm going to have the opposite of negative 1, which is going to be positive 1, plus and minus the square root of b squared, so negative 1 squared, minus 4 times the a value of 1 times the c value of 25, and that is all over 2 times a. Negative 1 times negative 1 is positive 1. So that's going to be positive 1 plus and minus the square root of negative 1 squared is 1. Right here, negative 1 squared is negative 1 times negative 1, 1, minus 4 times 1 times 25, which is going to be minus 100, because 4 times 1 is 4, 4 times 25 is 100. So then we have all over 2, just 2, because 2 times 1 is 2. Clean up this little tail here. Okay, moving along. Nice. This is working out. On the inside of the radical, we have 1 plus minus the square root. 1 minus 100 is negative 99 all over 2. Square root of negative 99. This is going to be interesting. Two things. First of all, the negative. I'm going to pull out I. If I'm taking the square root of a negative 1, that is I. So I'm going to pull out I. What else? Well, I have 9 times 11 would give me 99. Square root of 9 is 3. So I'm going to take out 3. So that's going to be 3i square root of 11. So we'll have 1 plus and minus 3i square root of 11 over 2. And you can write this as two different statements. You could say 1 plus 3i root 11 all over 2, or 1 minus 3i root 11 all over 2. I would just leave it as this. Like if I was asking a class to do this question on like an exam or something, I would just have them leave it like that. I wouldn't need to see the two separate solutions. Now there are times where you need to see that information and how that might help you out. But here, I think we're okay with just calling it that. So this is a deceiving problem. And like I said at the beginning, I multiply by 6 because I'm just in that habit of like, I want to wipe out these fractions. I see 6, let's clear it. But actually, we have an extra step there of dividing by 2. So it's kind of a win-win on that one. So there you go. Hopefully that was a good problem for you.